Number 4, let's start out by finding the vertex. So here we go. Let's find that vertex by using the formula x equals negative b over 2a. I want to start by just replacing the b and the a with parentheses. And the b value happens to be 2. And the a value happens to be negative 1/3. Let me zoom in right here. No, that's not zooming in. What's happening here? Here we go. So that was negative 1/3 for the a value. So I'm going to put a negative 1/3 right here. Wow, this one might be uglier than what I thought. We're going to multiply 2 over 1 times negative 1/3. That'll give us a negative 2/3. So I really have a negative 2 up on top, and on the bottom I have a negative 2/3. So, question? So 2 divided by a fraction, I hope you guys remember that dividing by a fraction is really the same thing as multiplying by the reciprocal. So I really have 2 times 3/2. Does that make sense? And 2 times 3/2, that ends up working out beautifully because the 2 and the 2 cancel out, and the negative times the negative equals a positive. So my answer is just 3 right here. Sweet, right? So the vertex x value is 3. Now we still need to find the y value by plugging it back in. So I'm going to rewrite this whole thing right here in black, but instead of x's, I'm going to put parentheses. And inside those parentheses, we're going to plug in the x value of 3. So when we work this out, we have 3 squared, which is 9. So I'm going to have a negative 1/3 times 9 plus, I might as well do 2 times 3, that's 6, and plus 3 at the very end. So when I multiply negative 1/3 times 9, put the 9 over 1, and you could actually cancel the 9 on top with the 3 on the bottom and have a 3 left over. So I really have negative 1 times 3, that's negative 3. So I have negative 3 plus 6 plus 3. So this negative 3 and that positive 3 cancel out. My answer is 6. So my vertex is 3, 6. Unfortunately, that's going to be a little bit off the graph, but who cares? Let's see if we could keep working with this. If not, it's okay. We at least know the vertex is 3, 6. So 3, 6 is going to be 1, 2, 3, 4, 5, and then 6, 1 off the graph. There's my vertex. Let's do an axis of symmetry, going right through that vertex. And we need some more coordinates. So let's use a quick XY table. What's the easy one to plug in? Zero. Cero entero. Gross. Why did I record that? Should I delete that? No, I'll just leave it on there, whatever. So we're plugging in 0. We get the C value, which is 3. So let's go 0, 3. That's the point right there. And you can map it over to the other side. If you do map it over to the other side, 1, 2, 3, it's 1, 2. It's off the graph over here also. So technically, this is your parabola. And that's good enough. Now, if you're only looking at the actual graph, though, if it was, that's the only thing you would actually see right there, like a weird looking curve. But that's it. I mean, you could put in more values, but that's already good enough. I could already see a nice parabola here, even though it's off the graph. But if you did plug in another value over here, it would just get you further down this way. So that's already good enough. The only thing else you'd have to do is to state your axis of symmetry. What's the axis of symmetry? X equals 3. The domain, x equals all real numbers. The range, y is less than or equal to 6. Again, so let me write this. The domain was x equals all real numbers. The range is y is less than or equal to 6. Because it's all below the value of 6. It's at 6. That's a max value. Everything else is below it. And we said the axis of symmetry, that was x equals 3. The y-intercept we could clearly see is this coordinate, 0, 3, right there. That's all there is that you could answer about this parabola. Got it? Since we have some extra time on this video, we might as well go and finish up any of these guys. Let's do number 2. That one's super easy, and I'm talking about number 2 on the right side. So quickly, if you think about the vertex, and the way to find that vertex is negative b over 2a, and when you think about it, there is no b value. Remember, standard form is this: ax squared plus bx plus c. Okay, so we do have an a value of 1 because that's an x squared. There is no bx, so the b would technically be 0, and the c value is negative 3. So when you think about the vertex formula, x equals negative b over 2 times a, you really have negative 0 over 2 times 1. But 0 divided by anything is still 0, so your x value of your vertex is 0, which means that your y value, that's really easy to do. You simply plug in your x value of 0 into it and work it out. 0 squared minus 3 is negative 3. So your vertex is 0, negative 3. So let's go to 0, negative 3. That's this coordinate right here. Okay, and we could draw an axis of symmetry. It's really not that important to draw the axis of symmetry because you could clearly see that the y-axis is that mirror line. It's that reflection line, the axis of symmetry. Anyhow, if they asked for the axis of symmetry equation, you would say x equals 0. That would be the axis of symmetry equation. Or you could also refer to it as the y-axis, the axis of symmetry. Anyhow, we need some more points. So you could go to a XY table and plug in some values that are on one side, like 1, 2. You could do 3, however many numbers you want for x. But the thing is, it's kind of pointless because this a value is 1, okay? Which means if the a value is 1, you could use the pattern 1, 1, 2, 4, 3, 9, okay? So from the vertex, you could go 1 out, 1 up. How do I know I'm going 1 out, 1 up instead of 1 out, 1 down? Well, the a value is positive 1. Remember, if it's positive, it opens up. If it's negative, it opens down. So again, I want to go 1 out, 1 up. That'll give me that coordinate right there. If I go to the next one, 2, 4, that means I want to go 2 out, 1, 2, 4 up, 1, 2, 3, 4. So that would be the coordinate 2, 1. And if I go 3, 9, okay, so if I go out 1, 2, 3, then I go up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, I'm off the graph. So you could put a dot up there, but you don't really have to. Anyhow, you could map them all over to the other side. So if I go to this one that's off the graph up here and I map it over 1, 2, 3 units from the axis of symmetry, 1, 2, 3 units from the axis of symmetry, I'd have a dot right there, right below the equal sign. And of course, if I map these other ones over, it's 1 unit away, go 1 unit away. And this other one is 2 units away, right? 2 units, so go 2 units this way. Put a dot right there. And there's your parabola, guys. You don't even have to go off the graph the way I did. You could, if you wanted to, draw it all the way up here. You don't have to draw it all the way up there. You could just you could erase this part, erase that part, and just put some arrows on it. It's the same thing. There's your parabola. So the other questions that you could answer is the domain. The domain on this thing is all real numbers. But I guess it's better to say x equals all real numbers, okay? Because domain are your x values. Now your range is going to be y, and the y values are going up or down. So all of this parabola is up here. It's not down here, it's up there. So all your y values have to be greater than means up, Greater than what? Greater than -3. And in this case, actually in all cases, it's greater than or equal to -3. You need the or equal to sign because the vertex is included. It actually does touch the y value of -3. And for the y-intercept value, you could clearly see already that it crosses the y at 0, -3. So the y-intercept is 0, -3. It's where it crosses the y-axis. So you have all these answers that you could have: the vertex, the axis symmetry, domain range, and the y-intercept. So I'm running out of time here, but I'm going to squeeze this one in. So the vertex is going to be a coordinate, and you're going to go -b over 2 times a. So that's -6 over 2 times -3. So we really have 6 over -6, and 6 over -6 is really -1. So the vertex x value is -1, and when I plug it in, I'm going to rewrite this equation, but instead of x's, I'm going to put a -1 right there and a -1 right there. So there it is. When I start out doing -1 squared, I get a 1, and 1 times -3 is -3. When I think about the -6 times -1, that's a +6, and then plus 2. So when I think of -3 plus 6, that's 3, and then 3 plus 2, the final answer is 5. So my vertex is -1, 5. If I go to the coordinate -1, 5, it's way down here. No, I'm sorry, way up here, -1, 5. Let me erase this bottom one. And of course there's an axis of symmetry going right through that vertex. Luckily this is opening down because it's negative, which means that it will fit down here somewhere. And let's get more coordinates, and the way to get more coordinates is to do a quick XY table. Okay, so the easiest point to plug in would be 0. And when you plug in 0, technically 0 for x, 0 for x, you're really finding the y-intercept value, which will be your c value, which is simply 2. So 0, 2 is right there, the coordinate 0, 2. If you wanted to plug in another number, let's say the number 1 would probably be a good number to do. Let's try to do this with the least amount of work possible. If I plug in a 1 right here, 1 squared is 1, and -3 times 1 is -3. When I plug in a 1 right here, it's going to be -6 times 1, so that's -6. And then we do have the plus 2 at the very end. So when I plug in a 1, I really get a -3 minus 6, that's -9. -9 plus 2 is -7. And yeah, this is going to be off the graph, so it's kind of difficult even to use that on this one. So 1, -7. You're talking about 1, -5, 6, 7. It's way off the graph. So I'm not even going to plot this one. I'm not even going to use the 1, 7. I'm only going to use the 0, 2. Let me map it over to the other side from the axis of symmetry. So if it's 1 unit away, I map it over 1 unit away, and I put a dot right there. And I just draw my parabola. Should have made it a little more curved right there, sorry. But this does continue down, way down there. You could put some arrows. You don't have to make it that far down. You could just keep it close to the points. I mean, that's already a good enough parabola. You just put arrows right here. Okay? So your domain is x equals all real numbers. Your range is y has to be less than or equal to 5. And your axis of symmetry is x equals -1. That's about it.